Hi, my name is Wang Shen. I'm now doing the homework 10 of probability and stochastic processes. I'm now doing the question 2. Let's see the question from the lecture notes. Page 1 to 50, correct definition of the property of stochastic processes. And first of all, let's see the YSM stationary processes. YSM stationary processes, and we say that a real stochastic process xt is stationary in the wide sense if its expected value is a constant, and its auto correlation depends on T1 minus T2, which is only when expect value of xt equal to eta, which is equal to constant, and expected value of xt plus tau multiply xt equal to r tau. And we know that wide sense stationary process it means that the expected value, the mean is constant, and the autocorrelation is a function of the time difference. So we can, based on the mean and the autocorrelation, we can do some state estimation, parameter estimation, and something else. And the second one is independent increment processes, which is xt1 minus xt2 and xt3 minus xt4 are non-overlapping intervals are independent. It's pretty obvious that if these two intervals are non-overlapping, and so these two are independent. And the third one is Markov processes. The definition is a process xt is a Markov process if the past has no influence on the future, while the present is known. And from the definition, we also know that a Markov process is statistically determined of one knows its second-order distribution function. This is Markov process. And the first one is normal process, which is Gaussian process. And the definition of the normal process is this. And the normal process we all know that the statistic of normal process is completely determined in terms of mean eta t and autocorrelation are T1, T2, or autocovariance C T1, T2. And so we classified Wiener process as one example of stochastic processes. And the fifth one is strict sense stationary process. And a process is said to be a strict sense stationary process if its statistic is not affected by a shift on the time axis. So because strict sense stationary process is require fx of x1 to xn and t1 to tn equals to fx of x1 to xn and t1 plus epsilon to tn plus epsilon. So this condition is very hard to meet. And the sixth one is white noise. We know that Vt is zero mean white is a zero mean, which is white noise. If R Vv of T1 and T2 equal to Q T1 multiply theta T1 minus T2, and white noise actually is a process such that it values at different times xt1, xti, and xtj are nearly independent, and actually they are uncorrelated. And last one is mean ergodic process, and a process is a mean ergodic process if limit of t is approaching infinity, 1 over 2 multiply t, the integral of minus t to t xt dt equal to expect number of xt in mean square sense. And so we can know that the mean ergodic process, this is a definition of the mean ergodic process. And actually we know that expect number of xt must be a constant, and mean square sense means that the limitation limit of t equal to infinity, the expect number of 1 over 2t, the integral of minus t to t xt dt minus eta to the power of 2 equal to 0. So this is the mean ergodic process, and this is question 2.